So far we've looked at trigonometry problems that look to find a missing side or an unknown side. Here we've got a situation where we're looking for an unknown angle. Now this situation would arise like this. We'd have a right triangle with an unknown angle here, but we know the sine of the angle. The sine of the angle is 0.8. 0.8 is the decimal of 4/5. Okay, so we know that the sine of angle x is opposite over hypotenuse 4/5, 4/5, 0.8. The object is to work backwards now and find the angle, the size of angle x. It's very similar to working backwards with squares and square roots. If we know that x squared is equal to 49 and we want to find the value of x, what we're looking for is a number that when multiplied by itself is equal to 49. So we're looking for the square root of 49, which is 7. Now in a calculator, sometimes the scientific calculators have a square root button. Other times the square root is written on the top of the x squared button. You'll see the square root like that, which means you've got to hit second function and that will be a square root. And the same applies here. What we're going to be using is a second function of the sine function, which is called the inverse sine. So the angle x is going to be the inverse of the sine function for 0.8. And in this case I put the 0.8 in brackets because we don't like having two numbers side by side. This is a representation, the inverse of a sine function. It's not a true index, as in 3 to the power negative 1 would be 1 over 3 to the power 1, or 1/3. Whereas this doesn't mean 1 over sine theta, it means the inverse of sine theta. Turn my calculator on and I want the inverse sine of 0.8. Now I don't have a sine to the negative 1 button on this calculator, but I do have sine to the negative 1 above the sine, which means I hit second function sine and I want to put in 0.8. I may or may not close the bracket. I try to keep that as a good practice. Enter. 53.13 equals 53.13 degrees. Okay? So, using inverse sine, given the sine of an angle, we can find the size of the angle, 53.13. Now this, of course, is a 3-4-5 right triangle, and the angles in a 3-4-5 triangle are 53 degrees 8 minutes, and 36 degrees 52 minutes up here. This would be 36 point something, this one's 53 point something. And it never changes. Every 3-4-5 triangle will have these same angles. Okay, let's do another one. Let's say we've got a situation like this, where we know 3/4, and we want to know the size of that angle, x degrees. Now, here we've got the opposite side and the adjacent side. So clearly we need to use tan. And we know the tan of this angle, tan of x degrees, is equal to opposite over adjacent, which is 3/4, which is 0.75. And so x degrees will be the inverse tan to the negative 1 of 0.75. Okay, so I clear my calculator and I put in inverse tan, which is second function tan of 0.75, close the bracket, enter, 36.86989, so 36.87, 36.87 degrees. So again we're looking at a 3-4-5 triangle, aren't we? So 53 degrees, 53.13 down here, and 36.87 up here. Okay, so this would be the 5, this would be the 3, and these are the angles, 53.13 and 36.87, that are in every 3-4-5 triangle. And they're also in every 6, 8, 10 triangle, and every 9, 12, 15 triangle. These are the angles in those triangles. Okay, so we set out what we know. The sine of the angle is 4 over 5.8. The tan of the angle is 3 over 4.75. And we use the inverse tan function to find the size of the angle. And in this case, the inverse sine function to find the size of the angle.